Good morning, everyone. Happy Thursday. Let's talk about what we're doing today. This is going to be a longer video just because we're going to be talking about this project that we're starting today. So yesterday, hopefully you looked at your 4 project options. If not, they're in today's assignment as well, or you can go back to yesterday's, but it'll be easy just to get them from today's. And you'll see that we have 4 different possible projects you could choose from. You're not doing all 4, you're choosing one of the 4. So you could do paper protector, paper tower, paper bridge, or paper table. And so for each one of these, what we call one-pagers about each project, it's going to help you figure out which one you want to do. So for the paper table, your problem statement, or what you're asking is, how do I build a table out of paper to support my math textbook? Now, if you're not in math right now, you might not have a math textbook, or you might not have a math textbook in general. So just any textbook that you have, whether it's yours or a sibling's, if you don't have a textbook, let me know and we can find something similar. But can I make basically a table out of paper? And you have your requirements. Just like with our airplanes that we did the past couple of days, there's problem statement, requirements, materials for that first part of the engineering design cycle. Requirements. The table must be tall enough to fit a regular-sized pop can underneath. If you don't remember or don't have a pop can, you can Google how tall a pop can is. It's about that big. So you can Google how tall that is. The table must be created from the limited materials, which is next. And the table must support your math textbook. Again, any textbook would work. Materials. You can only use 10 pieces of paper, 1 piece of cardboard, which is the size of a piece of paper, 60 centimeters amount of masking tape, or really any tape. Any tape that you have on hand will work. 2 times the length of your Chromebook. So 60 centimeters is 2 times the length of your Chromebook. So you just take the tape, stretch it across your Chromebook, then stretch it across it again. And then also on each one-pager, we have investigate possible solutions to help you research, because you have to do research as our next step in our lovely engineering design cycle. So for the paper table, you can ask these questions or Google these questions. How can paper be shaped to make stronger structure? So think about, how can I do that? Think about, how can you support the table legs to keep them from tilting or twisting? So how can I make that paper strong and not twist? How level and big does the table's top need to be to support the textbook? Because if you make a table that's only as big as this eraser and you try to put an entire textbook on top, that might not work. And then what structure does a table have? How many legs? Because normally a table has 4, but would it be better only to have 2 or 6 or 12? So think of these questions as you start to work on your project. So that's for paper table. Next is the paper bridge. So your problem here, how can we make a simple, inexpensive, but sturdy bridge? Sturdy means strong, it's not going to fall. Your requirements for this one must be longer than your Chromebook. So basically the bridge has to be able to go over the Chromebook. Again, Chromebook is about 30 centimeters. The bridge should be able to hold your math textbook. So again, textbooks, any textbook or large book will do. And then only use supplies that are in your materials. Materials, again, you get 10 pieces of paper. Again, you get 60 centimeters of tape, twice the length of your Chromebook. And then you have to use a textbook or math textbook or whatever you have. And then some possible things to investigate. How can paper be shaped to make a stronger structure? What shape makes a bridge sturdy and strong? How wide should the bridge be to make it sturdy? What are the different types of bridges? So these are possible things that you can research. Most likely, you could try just Googling that sentence, but you might have to Google a couple of things related to that, like how to make paper strong. So that is paper bridge. Next is paper tower. Problem, how do I build the tallest freestanding tower possible with the limited supplies? So you're trying to build a very tall tower, and freestanding, Oh, and a requirement, each tower must be freestanding. It must not be attached to or lean against any other surface. So you can't like tape it to the ground or your table or anything like that. You can't tape it to a wall. You can't lean it against a wall. You have to be able to just like set it somewhere and have it stand by itself. So each tower must be constructed from the limited supply of paper and tape, and the tower must support a paper clip at the top. So it has to be able to support something up top. Your materials. Again, 10 pieces of paper, 60 centimeters of masking tape, and 1 paper clip. So this is the one where you don't need a textbook or anything like that. And possible solutions. Very similar. How can paper shaped be a stronger structure? How are tall skyscrapers designed? How do you keep the tower straight up? What are the proportions of a skyscraper? What size is the base compared to the top? So these are things to think about as you start to do your research and make your design. And last one, the paper protector. Your problem, how do I protect an egg from breaking on my kitchen floor? So this is similar to an egg drop, but you can only use paper and 60 centimeters of masking tape. Your requirements. You may only use the given materials to build your egg protection system. The egg must be removed after testing without destroying your protection system. So you can't just like crumple it in a ball. You need to be able to remove the egg from your protection system without just destroying it. So you can't just completely cover it. Then the egg must be protected from countertop height, meaning you're going to be dropping it from a counter. Or like a kitchen table might be around the same size, but a counter is a really good height to drop from, and that's what you should be using. And again, 10 pieces of paper, 60 centimeters of masking tape, and an egg. And also, most likely you will need some sort of mop or washcloth, just in case your tests don't go too well. Now, some possible solutions to investigate. How can paper be shaped to make a stronger structure? How can paper be used to protect? How strong are eggshells? What would help slow the eggs fall? So these are your requirements. That's all you have to make sure to do to not crack the egg. Those are the 4 that you can choose from. Again, you're only choosing 1. So let's say I choose paper protector. This is the project I want to do. I have my problem, I have my requirements, I have my materials, and then I have some possible things to investigate. Now let's go to our star slides. Our star slides this week, or I guess this week into next week, this is how we're grading your project. You're not going to be turning in a separate Google Sheet like you did with the airplane. These star slides are how you are turning in your project. You'll notice that all of these kind of green ones follow the engineering design cycle. So on this first page for today's star slides, you have problem, requirements, materials, and investigate possible solutions. So for problem, materials, requirements, and investigate possible solutions, you actually have them on your one-pager already. Although the problem, you can just copy and paste. For requirements and materials, try your best not to copy and paste those. Try to summarize them. 1, to make sure that we know that you actually read it, and 2, to help you process it. The reason that you summarize things that you already have is for you to think it through even more, because you have to think a lot about it in order to summarize it. So you have problem, requirements, and materials already given to you. And then investigate possible solutions. So you are not copying and pasting this into that section. These are just questions to get you started as you investigate. So in this box, this green box, you are writing down your research. So you are answering these questions in this box. And then you'll notice that at the top, it always says complete sentences unless it's a list or a picture. So for problem, requirements, materials, investigate possible solutions, requirements says list, materials says list. So you need complete sentences unless it says list. So you need complete sentences here and complete sentences here. And again, we are grading this for your project. So you need to do that in order to get your full grade. Something weird about star slides for today is that there's actually 2 Thursday star slides. Because after you do some research today about your project, we're going to hope that you start drawing your prototype. So in this box, again on a second Thursday, October 8th slide, it's asking you to use your research to draw a prototype. Measurements of the prototype dimensions. So just like you did for the airplane, you have to draw your design. And on that design, you also need extra details. So if you know measurements, like you know that a normal piece of paper is 8.5 inches by 11 inches. Although definitely make sure to write your dimensions in centimeters because we're in science and we use centimeters in science. But you know the dimensions of a piece of paper that way. And then on your prototype, if you are like cutting or ripping paper, or if you are crumpling a paper or twisting paper, let us know that. Especially if you are not the world's greatest artist, like myself, you might need some extra details in your design just so we know for sure what's happening. The point of these prototype drawings is to make sure that if you gave that to someone else, they could build the same prototype. These are blueprints that you are trying to make. So you can either make them in Google Drawings or you can sketch it out on a piece of paper. Either way, you'll take a screenshot of it or take a picture of it and upload it to this Thursday slide. This is what we are hoping that you get done by Thursday, and you might even get done more than that on Thursday. Or you might even get more than that done on Thursday. On Friday, we go into the next parts of our engineering design cycle. We move on to building what we drew before and then testing it. For your building, you're going to take a picture of what you built and insert it here. To insert pictures into a Google slide, you have a couple of different options that you can use for this as well as for your prototype drawing. So if you go to this box right here, it says insert image. You can either upload a picture that is either a screenshot or something you took from your webcam here, or you can just open up your camera right here and take a picture right there. For Friday star slides, you're going to include a picture of your design, and then you're going to test it. And so each one-pager tells you how you're supposed to test it. For your paper protector, you are trying to drop it from counter height and have it be protected, so not crack after dropping it off a counter. For paper tower, you're trying to get a very tall tower, and you're also trying to make sure it can support a paper clip at the top. So your test is putting a paper clip on top and seeing if it stands. For the paper bridge, you are trying to figure out if you can have your bridge hold your textbook or a large book. So your test is putting your textbook on the bridge to see if it stands. And for paper table, it's a very similar thing. You're again trying to have it support your textbook's weight. So you're making your table and then putting the textbook on top, and that is your test to see if it still stands. Once you've tested it, you're going to collect qualitative and quantitative data. You need at least 2 observations using words for qualitative and at least 1 observation with numbers for your quantitative. You can of course add more, but you can't have less. And then you also need this in complete sentences because it asks for complete sentences. Monday star slides, you are going to analyze your data and do a redesign. So you're going to ask what worked well, what didn't work, what changes need to be made, just like on your airplane. And then just like on your airplane, you're going to redesign. So please include a drawing or picture of your redesign. Again, using either Google Drawing or sketching it out by hand. And Tuesday star slides, this is when you're doing your conclusion. We used this rerun conclusion on your airplane where you restate, explain results, uncertainties, and next steps. So you're gonna do that same thing in this conclusion, but this time it has to be in complete sentences. A lot of the conclusions you guys submitted to me were just fragments, sentence fragments, and that's totally fine, but for your summative project assignment, it has to be in complete sentences. These are your star slides. Thursday, you are working on these 2 star slides, and then you have the rest of these, and you know what you're doing with the rest of them. And the nice thing is, if you get done with Thursday early, so you have extra time either in class or at home, you can go ahead and start working on Friday and start building stuff if you want. You can build it and maybe even test it depending on how much time you want to put into it today. You could even go on to Monday and Tuesdays early because you have these star slides available to you. Now, that does not mean you should get them done on Thursday. You should just make sure to get Thursdays done on Thursday, and if you have extra time, you can move on. You should not try to rush to get everything done because most likely it won't be your best work, and then you'll have to do it over again because we're going to ask you to redo it because it just wasn't done to the quality that we expect from you. To summarize, work on Thursday's 2 star slides today. If you have extra time, go on, but make sure that you are doing these in top project quality. For the rest of the assignment just has some videos for you to watch about these steps of the process. So talking about how to find a problem, talking about what requirements are, talking about materials, talking about how to research, and there's a couple of resources for research in the assignment as well. So you're not just going to stay in the star slides. There's some stuff in the assignment to do as well, but it's mostly in the star slides. Now, this has been a very long introduction video. If you lasted through the whole thing, I'm very proud of you, and let me know if you have any questions. Thanks so much. Bye.